So I have a quick question here. So what's the question? The question is that I have a flow of zero point 0.5 meter cube per second going from a treatment plant, okay, where we are doing some alum dosage of 23 milligram per liter, okay, and only alum dosage, okay. So if I have a rough water, it has the suspended solid concentration of, let's 37 milligrams per liter, and the effluent means after the treatment, the water which is coming out, that's called as effluent, and it has a suspended solid concentration of effluent effluent it has a suspended solid concentration of 12 milligrams per liter, okay. And the sludge content means the thing which we usually take out from the treatment plant. So it is somewhat slurry type. So it consists of both solids which has been set down, and the water. Okay. The solid content. What is going about that? So the solid content of the sludge is 1%, and specific gravity is 3.01. Okay, and asked to determine we are asked to determine the of sludge volume of sludge that must be disposed per day, okay, from this treatment plant. So basically, what we are going to focus on first we'll focus on this part. So basically, the alum dosage, that's 23 milligrams. So we'll see that this this alum will not precipitate as it is, so it will first convert to FeOH whole thrice. Okay, it will first convert to FeOH whole thrice, and we know that and we know that uh, we know that one so 1 gram of alum 1 gram of alum produce 0.234 grams of AlOH whole thrice, which will precipitate. Okay. So similarly, if this is 23 grams, so it will be 23 multiplied by 0.234. So this comes out to be 5.382 grams. Okay. So therefore, this becomes that we are getting from this 5.382 grams per liter, sorry, milligrams per liter. This is milligram and this will be milligram as well. Simply unitary method. By unitary method, we are doing this calculation. So this we can also calculate from the uh, normality method or equivalent method. Number of equivalents, number of gram equivalents of alum will react with one equivalent of alum will react with one equivalent will produce one equivalent of this AlOH whole price. Okay. So from that we can calculate this. So now we got this information from here. Now what we can do is we can conclude some points. We can say that for we'll calculate for 1 liter first. So for 1 liter, 5.382 milligram will settle, which will come from this alum dosage. And if you can see that the raw water suspended solid concentration will change from 37 to 12, that's 25 milligrams per liter, 25 milligrams per liter, milligrams. This also will settle down. Okay, so these many things means 30.382 milligrams will become sludge. This will become sludge from per liter. Okay. Now we'll see from for 0.3 meter cube per second, meter cube per second. Okay. So uh, we'll see how much sludge will be there with respect to time. Okay. So simply we'll multiply this 30.382 milligrams per liter into 0. This is 0.5. 0.5. This is 0.5 meter cube per second. So I'll change first this 10 to the power minus 3 meter cube. Meter cube will cancel out, and this will be 0.5 to the 10 to the power minus 3. So this will be 15191 milligrams per second. Simply now I'll convert this to day because I need per day, so I'll convert this to day. So this will become, I have to multiply this by 60, 60 and 1024. Okay, so this will become something big term, and I'll convert this milligram to kg. So divide by 10 to the power minus 6, divide by 10 to the power 6. So this will become 1312.5024 kg. So meaning that this much of solid is in sludge. Per day, this much of solid gets deposited. Okay, gets deposited, and this some part of sludge. But as we know, the sludge consists of both water and this solids. Now, how we can calculate the solids, as we have given that there is this value is this 1% here, solid content of 1% is there. So if there is solid content of 1%, so 1% means 1% means weight of solids divided by weight of solids plus weight of water, which is present in sludge. Okay. So weight of solids, it's given 13 into 100. It's given 1312.5024 divided by 1312.5024, which is equal to 0.01. Okay. So this and the weight of water. So we'll now calculate the weight of water, which is present in sludge. It will be 1312.504. It will be 129937.736 kg. And if I calculate this to volume, it will become simply divide by 1000. Simply divide by 1000. So it will become 129.93 meter cube. And if I calculate the solids is 1312.5024 kg. So if I calculate this to volume, I have to divide this by 3010 because the GS is 3.01. Okay. So 1312.5024 divided by 3010. So it's coming out to 0.43 0.36 meter cube. Okay. So total volume will simply be the sum of these two volumes 129.93 plus 0.436. So it will be 130.366 meter cube V total. So this will be the correct answer for this question. Thank you.